What if the universe is expanding into something that shouldn't exist? It's a question that seems almost forbidden, a thought experiment that bends not just the rules of physics, but the boundaries of imagination itself. When we think about the expansion of the universe, we often picture galaxies drifting apart through an endless cosmic backdrop. But what if that backdrop wasn't endless? What if the universe were pushing its way into a region, a realm, a domain of existence that, by all logic, by all physical reasoning, shouldn't even be there? This possibility forces us to confront something deeply unsettling. The idea that the universe might not merely be expanding within itself, it might be expanding into something external, something whose nature challenges the very foundations of reality. And if that's true, then everything we know about space, time, and existence could be just the thin outer layer of a much deeper mystery. For a moment, imagine standing at the edge of a colossal field shrouded in fog. You can only see a few meters ahead, but you sense the field extends far beyond what your eyes reveal. Now imagine that with each step you take, the fog peels back, revealing more terrain. But what if the field isn't actually there until you walk into it? What if your steps create the ground beneath you? This is the kind of paradox that cosmologists face when trying to understand the expansion of the universe. Space doesn't simply stretch, it unfolds. It emerges. But emerge from what? Expand into where? These are questions that push the limits of our physics, and yet they refuse to go away. For decades, the standard answer has been simple, almost too simple. The universe isn't expanding into anything. Space itself is growing, and there is no external region for it to intrude upon. In this view, the universe is self-contained, its geometry a complete and closed mathematical object. But that explanation works only if we accept that our familiar intuition of things expanding into spaces larger than themselves is irrelevant at cosmic scales. And while this model fits the equations, it leaves behind an itching curiosity. What if our intuition is correct after all? What if there really is an outside, a realm beyond space-time, into which the universe is spreading like the surface of an inflating bubble? To explore this idea, we must first face a strange truth. Everything we observe, from galaxies billions of light years away to the radiation left over from the Big Bang, lies inside what cosmologists call our observable universe. But the observable universe is not the full universe. It's merely the sphere of space we can see, limited by the speed of light and the age of cosmic expansion. Beyond that sphere, space continues, maybe infinitely, maybe finitely, maybe looping back on itself in ways we can't imagine. But if space continues, the natural question is, what sits beyond even that? And if the universe is growing, what is the nature of whatever lies beyond its boundary? This leads us to consider something astonishing. Perhaps the universe is expanding into a realm with no physical properties at all, no dimensions, no time, no laws, a kind of meta-reality where the rules of our universe simply do not apply. If this is true, then the expansion of the universe might be better understood not as movement into space, but as the creation of space from the void. Yet even describing it as a void is misleading. The word void implies emptiness, but emptiness is still a property. It still describes something. But what if the beyond is not empty? It's non-existent. What if the universe is expanding into a zone where existence itself has no meaning? Imagine the universe as a growing bubble, but the bubble is the only thing that exists. Beyond its surface is not air, not vacuum, not darkness. Beyond its surface is the absence of anything that could be called beyond. The universe doesn't expand into a void. It expands by pulling the fabric of space-time outward from itself, like a magician pulling silk from his sleeve, seemingly out of nowhere. This doesn't violate the laws of physics. This defines the laws of physics. And yet, even this poetic picture leaves us with a nagging question. If the universe is generating more space-time with its expansion, is it doing so in a place that previously didn't exist? Or is it expanding into a substrate, a cosmic canvas that has been waiting all along? To dig deeper, we must examine the Big Bang not as an explosion, but as a transformation. The classical image of a singularity, a point infinitely dense, infinitely small, containing all matter and energy, is a simplification. Modern cosmology paints a different picture. The entire universe emerged from a hot, dense state that filled all of space, and as time passed, that space expanded. But what if that hot, dense state was only one phase of a much bigger process? What if the Big Bang wasn't the birth of the universe, but the moment the universe broke into a larger realm where its existence wasn't just unlikely, it was impossible? Here is where things become truly strange. In many models of cosmology, the universe could be the interior of a higher dimensional structure. Think of a three-dimensional sheet embedded in a multiverse of higher dimensions. If so, the expansion of our universe may be nothing more than the stretching of that sheet into surrounding dimensions. But what if those dimensions are unstable, unruled, or incompatible with the laws of our universe? What if our cosmos is expanding into a region where physics should break down, where the very idea of space is a contradiction? Could the universe be pushing against the boundaries of metaphysical possibility? If that's the case, then what we call expansion might be a form of cosmic trespassing. The universe could be intruding into a domain where it doesn't belong, carving out a pocket of lawful reality inside a realm of pure potential or absolute nothingness. In this scenario, the expansion of the universe is not gentle growth, it is a battle, a fight between existence and non-existence. And the universe, through the fundamental architecture of space-time, through dark energy and the acceleration of expansion, continues to push outward, forcing its own laws into regions where no laws existed before. But how would we ever detect such a possibility? Would the universe show scars, fractures, or anomalies near its farthest edges? Would cosmic expansion behave differently at its frontier than near its center? And is there even a center to such an expanding reality? These questions haunt physicists and philosophers alike. One possibility is that the acceleration of cosmic expansion, driven by dark energy, is a sign that the universe is pushing into forbidden territory. Dark energy might be the tension at the frontier of existence, the pressure exerted by whatever lies beyond, or the energy required for the universe to carve out new space-time from non-existence. And then comes the most unsettling idea. What if the universe cannot expand forever? Because eventually, it will reach something it cannot penetrate. A metaphysical wall, a dimensional boundary, a limit imposed not by matter or energy, but by the fabric of possibility itself. If such a boundary exists, what would happen when the universe reaches it? Would expansion slow? Would it reverse? Would space-time rupture at the edge? Would the laws of physics collapse? Or would the universe be forced into a new phase of existence altogether, one where our understanding of reality becomes obsolete? These questions are not whimsical. They tap into fundamental mysteries of the cosmos, the nature of dark energy, the topology of space-time, the possibility of higher dimensions, and the limits of physical law. And they force us to reconsider something profound. Maybe the universe is not expanding into nothing. Maybe it's expanding into something so foreign, so incompatible with reality as we know it, that calling it something is already a category error. Maybe the universe is expanding into impossibility. And if that's true, then our universe, this vast cosmic structure of galaxies, stars, atoms, and consciousness, is not just improbable. It is a rebellion against the constraints of existence. If the universe is expanding into something that shouldn't exist, then we must ask ourselves a question more profound than any we have confronted so far. What, exactly, defines the boundary between existence and non-existence? To explore this, we must travel deeper into the architecture of space-time, peeling back layers of abstraction until we reach a level where language itself begins to fail. At these frontiers, words like before, outside, beyond, and even exist stop behaving normally. They bend under the weight of cosmological meaning. And yet, if we want to understand what the universe might be expanding into, we must be willing to let these words break. Because whatever lies outside the universe, if anything lies there at all, cannot be described in the vocabulary of the world we know. When we imagine the expansion of the universe, we picture galaxies drifting apart, space thinning like a stretched fabric. But this image is incomplete. The expansion of space is not simply a movement, it is a transformation. Space does not grow inside a container, it generates its own container. And so the question becomes, is the universe generating a legitimate region of space-time as it expands? Or is it forcing itself into a realm where space-time should not be able to form at all? If the latter is true, then the laws of physics are not merely governing the universe, they are defying something outside it. This idea challenges everything we think we know about natural law. It suggests that the universe is not passively evolving, but actively conquering. To understand how radical this idea is, consider a simple but unsettling analogy. Imagine a flame spreading across a surface. It consumes the fuel it burns, converting it into heat and light. But now, imagine a flame spreading across a surface that has no fuel, a flame that expands into nothingness. What would it burn? How would it grow? What would sustain it? The flame in this analogy is space-time itself. The universe is not fueled by anything external, and yet it grows. Why? Into what? And what happens if it tries to expand into a region where expansion is forbidden? This thought leads us to consider the concept of dimensional compatibility. Our universe has a particular structure, 3 spatial dimensions and 1 time dimension. Everything that exists, from quarks to galaxies, depends on the delicate properties of those dimensions. But what if the region beyond the universe is not 4-dimensional? What if it has no dimensions, or too many, or dimensions that are incompatible with ours? If so, then when the universe expands, it may be trying to impose its structure onto a realm that simply does not support it. This raises an extraordinary possibility. The expansion of the universe may be a process of dimensional colonization, but if the universe is colonizing dimensional territory, is there resistance? Is there a kind of metaphysical pressure pushing back? Could this pressure be what we observe as dark energy? Many physicists believe dark energy is an intrinsic property of space-time, a cosmological constant that accelerates expansion. But what if dark energy is not intrinsic at all? What if it is the reactive force produced by the universe encountering a region where existence is not permitted? In this view, dark energy is not a calm, passive field. It is a shockwave, a sign that the universe is pushing into forbidden space. The acceleration of expansion then becomes not a gentle stretching, but the result of cosmic resistance. This perspective reframes the Big Bang. Instead of thinking of it as the beginning of everything, we can imagine it as a breach, a rupture between non-existence and existence, a moment when the universe did not merely appear, but invaded a region beyond its rightful domain. If this is true, then space-time is not just expanding, it is invading, and the frontier of the universe is not a peaceful boundary, but a battleground between possibility and impossibility. But how could we test such an extraordinary idea? How could we detect signs that the universe is expanding into something hostile to existence? One way might involve studying the cosmic microwave background, the afterglow of the Big Bang. This radiation is not perfectly uniform. There are small fluctuations, tiny temperature differences that tell us about the early universe. But what if some of those fluctuations are not random? What if they are stress marks? What if they are scars left by the universe trying to stabilize its own borders? Some scientists have looked for anomalies in the cosmic background, cold spots, unusual alignments, patterns that defy standard cosmology. These anomalies are controversial, but their existence raises a tantalizing prospect. Perhaps the universe remembers its struggle against non-existence. Another clue may lie in the nature of cosmic inflation, the brief period after the Big Bang when the universe expanded faster than the speed of light. Inflation is already one of the most mysterious events in cosmology. But what if inflation wasn't merely rapid expansion? What if it was the universe's response to a catastrophic threat, a desperate attempt to establish enough of its own space-time before external conditions could collapse it? In this scenario, inflation becomes not just an explanatory mechanism for the universe's uniformity, it becomes a survival strategy, a cosmic sprint to carve out a stable domain within a realm where existence was initially forbidden. This leads us to a profound implication. The expansion of the universe might not be optional, it might be necessary. Perhaps the universe must expand in order to remain stable, in order to continue existing. If the universe stopped expanding, maybe the surrounding realm, whatever it is, would begin to crush it, or dissolve it, or overwrite it. Expansion then becomes not a passive feature, but an existential requirement. The universe grows not because it can, but because it must. This raises even deeper questions about the nature of time. If expansion is required for existence, then time itself might be tied to the need to create new regions of space-time. Time could be the internal clock of expansion, the process by which existence pushes further into a region that resists existence. If time is linked to expansion, then the slowing or reversal of expansion might lead to the collapse or distortion of time. And if expansion ever stops entirely, time might cease to have meaning within the universe. But if the universe is expanding into something that shouldn't exist, what happens at the frontier, the true edge of cosmic reality? Not the edge of the observable universe, but the edge of the universe itself? This edge is something we cannot see, cannot reach, cannot even define fully. But if it exists, it might contain clues about the nature of the beyond. Perhaps the laws of physics near the frontier behave differently. Perhaps space-time is thinner there, or more fragile. Perhaps quantum fields fluctuate wildly. Perhaps particles behave unpredictably, torn between existence and non-existence. These effects would be infinitely subtle, invisible to any instrument we possess. And yet, they might shape the evolution of the universe in ways we can infer indirectly. Another possibility is that the frontier is not smooth. Perhaps the universe does not expand evenly. Perhaps some regions push outward more easily, while others encounter more resistance. This could create asymmetries in cosmic expansion, large-scale patterns in the distribution of galaxies, subtle warps in space-time geometry. If such patterns exist, we may one day detect them. They would be the fingerprint of the beyond, imprinted on the universe, like waves on a pond, disturbed by an unseen force. But the most dramatic possibility of all is this: the universe might eventually collide with something. Not another universe, not a physical object, but a boundary, a limit, a region of absolute impossibility. If such a collision occurs, what would we experience? The collision would not be like a physical impact. It would be like running out of reality. The laws of physics might begin to fail at the edges of the cosmos. Space could fray, time could distort, quantum fields could destabilize, and the effects might propagate inward, not instantly, but gradually. A slow collapse of structure, a quiet unraveling of the tapestry of existence. If this frontier moves inward faster than expansion pushes outward, the universe could be consumed by non-existence. But if expansion always outruns collapse, the universe could survive indefinitely, constantly pushing into the impossible. This raises a haunting question. Is the accelerating expansion of the universe a sign that it is outrunning destruction? Is dark energy the universe's defense mechanism, the force that keeps collapse at bay? And yet, there is another possibility, one even stranger than the rest. What if the universe is not the only entity expanding into this forbidden realm? What if other universes are emerging, expanding, intruding as well? In that case, the beyond is not merely a blank slate. It is a chaotic frontier populated by countless bubbles of existence, each carving out its own pocket of space-time. These universes might collide, overlap, merge, or annihilate each other. Our universe might be just one of many cosmic invaders, each trying to survive in a realm where survival is improbable. This scenario transforms the cosmos into a battlefield of realities. Existence becomes a competition, and expansion becomes a strategy. Our universe might be winning, for now, but if we are surrounded by other expanding regions of incompatible physics, then one day a collision could occur, and the result would be catastrophic. Not an explosion, not an impact, but a rewriting of physical law. The invading universe might overwrite our space-time, replacing it with its own structure. To us, this would appear as the sudden collapse of everything, the end not just of matter and energy, but of the rules that give them meaning. Such possibilities stretch the imagination to its breaking point, but they are not illogical. They follow from a simple premise. If the universe is expanding into something that shouldn't exist, then existence itself is precarious, fragile, contingent, and the story of the universe becomes not a gentle unfolding but a cosmic struggle. If this is true, then the expansion of the universe is not just an astronomical fact. It is the most important thing happening. It is the process by which reality protects itself, and we, tiny beings on a small planet, are passengers in this grand expansion, unaware of the vast metaphysical forces shaping our existence. What if the universe is expanding into something that shouldn't exist? Not just in a metaphysical sense, not simply into nothingness, but into a domain so fundamentally incompatible with our reality that the act of expanding into it introduces paradoxes into the structure of space-time itself. To explore this, we must go deeper than cosmology normally dares. We must consider not only the physical consequences of expansion, but the possibility that our universe is interacting with, or imposing itself upon, a substrate beyond the conceptual reach of physics. This raises a frightening possibility. The very expansion of the universe could be straining the limits of what is allowed, slowly pushing cosmic reality toward a tension point where something unprecedented may occur. But before we consider what might happen if the universe reaches such a point, we first need to understand how deeply the expansion of space-time is tied to the universe's survival. Imagine, for a moment, that the universe is not simply growing, it is actively preventing collapse. In many cosmological models, the pressure-driving expansion, dark energy, seems to be fine-tuned to ensure the universe neither collapses nor tears itself apart too quickly. The balance is delicate, almost unnervingly so. And one interpretation is that this balance reflects a deeper truth, that expansion is not a passive byproduct of initial conditions, but an essential mechanism by which the universe maintains stability against external conditions beyond its border. If the universe is expanding into a domain that shouldn't exist, then failure to expand could expose it directly to whatever lies beyond, something that might be fundamentally corrosive to existence. Let us consider what this corrosiveness could be. It might not be anything like matter or energy. It might not have forces, particles, or fields. Instead, the beyond might simply be absence of structure, a region where the prerequisite conditions for existence, dimensionality, symmetry, time, are absent or fluctuating. If our universe expands into such a region, it's not pushing into space. It's imposing structure onto a place where structure cannot naturally arise. And if this is true, then the universe is not expanding into a container, but generating a domain of stability within a fundamentally unstable backdrop. Expansion becomes the act of solidifying existence, like freezing water into ice over a turbulent sea. But what happens at the frontier where structured spacetime meets unstructured non-existence? This boundary is not like the surface of a balloon. It is not a smooth shell. Instead, it may be jagged, irregular, filled with distortions and quantum anomalies. The boundary might be a war zone of competing realities, with space-time constantly attempting to stabilize itself against a surrounding environment that tries to dissolve it. At this frontier, the geometry of space could fluctuate wildly. The vacuum energy could spike unpredictably. Quantum fields could behave in ways impossible within stable space-time. It might be a region where probability itself buckles under the strain of existing next to non-existence. If such a frontier exists, then it may be expanding outward at the speed of causality, pushed by the accelerating expansion of the universe. But here is where things become even stranger. What if the expansion is accelerating because the frontier is becoming harder to maintain? What if the universe must expend more energy, more dark energy, to impose structure on an environment increasingly resistant to structure? In this sense, dark energy could be the universe's effort to preserve itself, to hold open a pocket of stable reality in a sea of metaphysical instability. This reframes a long-standing mystery. Why is dark energy constant or nearly constant? Why is it not decaying or fluctuating wildly like quantum fields normally do? One answer is that dark energy is a balancing force. It exists to maintain the boundary of the universe. It is the cost of existence, the energy required to keep the frontier from collapsing. And if this is true, then the universe's expansion rate is determined not just by internal physics, but by the nature of the non-existence beyond it. Let's consider another layer of this idea. If the universe is expanding into a domain that should not permit structure, then the frontier might represent a kind of cosmic stress point, and stress points fail, they fracture. If the frontier were to fracture, what would that look like from within the universe? Perhaps we would observe sudden distortions in space-time. Perhaps pockets of reality would destabilize. Regions of the universe might experience anomalies, unexpected warping, unexplained fluctuations in vacuum energy, or catastrophic disruptions in cosmic structure. These disruptions might appear as cosmic voids that grow faster than cosmic expansion predicts, or as cold spots in the cosmic microwave background, or as anomalies in the distribution of galaxies that cannot be explained by standard models. Some cosmologists already suspect that the universe contains such anomalies. They often attribute them to statistical noise, observational error, or unknown astrophysical processes. But what if these anomalies are symptoms of frontier failure? What if they are the early signs of the universe encountering something fundamentally incompatible beyond its borders? At this point, we must confront a question almost too large to grasp. What if the universe does not have infinite room to expand? What if the domain it is expanding into has limits? Not physical limits, but metaphysical limits. What if there is a threshold beyond which the universe cannot impose space-time? A threshold where existence meets a wall of impossibility. If such a threshold exists, then the universe could eventually reach it, and the consequences could be profound. Expansion might slow, it might distort, it might reverse, or the frontier might collapse, causing the entire universe to destabilize from the outside inward. To imagine such a collapse, picture a bubble submerged in a liquid that does not tolerate bubbles. As the bubble grows, the pressure increases. Eventually, the bubble reaches a size where the surrounding medium begins to crush it. The collapse does not happen all at once. It begins at the edges, where the medium can exert the most pressure. Similarly, if the universe expands into a domain where existence is not allowed, the frontier might begin to crumble at its farthest edges, triggering a wave of collapse that travels inward. But perhaps the universe anticipates this danger. Perhaps that is why expansion is accelerating. The universe may be trying to outrun collapse, expanding faster than the resistance can build. If so, then the universe is not merely growing, it is escaping from a domain that threatens its existence. Expansion becomes a flight from annihilation, a race the universe cannot afford to lose. This possibility leads to a startling interpretation. Perhaps the universe expands not because of dark energy, but because of fear encoded in the mathematical structure of space-time. A fundamental drive to survive against a metaphysical environment hostile to reality. In this picture, the universe is a living process, not biologically, but structurally. Its expansion a kind of survival instinct written into the equations that govern it. But what if the domain beyond our universe is not uniform? What if some regions resist existence more strongly than others? Imagine the universe expanding into a terrain of varying resistance. In some directions, expansion proceeds easily. In others, the frontier struggles. This could produce anisotropies in cosmic expansion, subtle directional differences in how fast the universe grows. Perhaps we have already detected hints of this. Some studies have suggested the universe expands slightly faster in one direction than another, a controversial claim, but one that gains new meaning if expansion is not uniform because the beyond is not uniform. If the universe is expanding into something that shouldn't exist, then the frontier is not only a boundary between existence and non-existence, it is also a negotiation between the laws of physics inside the universe and the absence of laws outside it. And like any negotiation, it may involve compromises. Perhaps the structure of space-time inside the universe adjusts itself based on the conditions beyond. Perhaps this adjustment is reflected in the cosmic constants, the speed of light, the gravitational constant, the fine structure constant. If these constants have changed over time, even by the slightest amount, it could be evidence that the universe is adapting to its environment. Let us consider one more extraordinary idea. What if time itself emerges from the universe's effort to expand into impossibility? If expansion is necessary for stability, then time, the measure of change, becomes the internal clock of expansion. Without expansion, time might halt. Without expansion, existence might be consumed by the beyond. In this sense, time does not simply flow. It is created by the universe's need to grow. Time is the byproduct of survival. And what if one day, the universe reaches a region where expansion cannot proceed, where the resistance is overwhelming? Time might slow at the frontier, then slow everywhere else. Eventually, time might stop. The universe wouldn't collapse violently, it would freeze into stillness. A cosmic death, not by heat or cold, but by impossibility. But there is also a more radical possibility. Maybe the universe is not alone in expanding into the impossible. Maybe there are countless universes, each pushing into the same beyond, each struggling to survive. In this scenario, the beyond is not empty, but filled with the ghosts of realities trying to impose themselves. Some succeed, some fail. Collisions might occur, overlaps, interference patterns. And if our universe ever meets another expanding region of incompatible physics, the result could be catastrophic. A rewriting of physical law, a collapse of space-time geometry, a transformation of reality into something unrecognizable. In this vast landscape of metaphysical struggle, our universe is merely one bubble among many, and its future is uncertain. It might continue expanding indefinitely, carving out an ever-growing domain of existence. Or it might someday encounter a boundary it cannot cross, or another bubble of reality might crash into it, or the beyond might overwhelm it. Everything depends on the nature of that external domain, the domain the universe is expanding into, a domain that should not exist, yet somehow does. What if the universe is expanding into something that shouldn't exist? Not just a domain of non-existence, not merely a realm without structure, but into a deeper, stranger substrate that actively rejects the form and logic of our universe. To understand what that could mean, we must confront the possibility that the universe is not only stretching its boundaries, but also reshaping an underlying reality that predates space-time itself. This idea forces us to examine concepts even more elusive than nothingness, concepts like pre-geometry, meta-reality, and the primordial conditions out of which existence might emerge. If the universe is expanding into something that shouldn't exist, perhaps it is expanding into the raw fabric, not of space, but of potentiality, a domain where existence is only one of many possibilities, and perhaps not even the preferred one. Imagine for a moment that what we call non-existence is not empty, but unstable, not a void, but a swirling chaos of unrealized states, a frothing sea of proto-realities, each incapable of forming stable space-time. If our universe expands into such a domain, it doesn't merely occupy it, it overwrites it. Like a software program imposing its rules onto raw memory, the universe might be forcing structure onto a substrate that does not naturally allow it. This is not expansion. This is conquest at the most fundamental level, existence conquering unexistence. But why would such a substrate reject our universe? Perhaps because the rules that govern it, if it can even be said to have rules, are fundamentally incompatible with the rules of our cosmos. Consider that our universe relies on symmetry, on conservation principles, on stable dimensionality. If the region beyond the universe has no symmetry, no conservation, and no consistent number of dimensions, then expanding into it would be like trying to build a cathedral on shifting sands. The universe must constantly reinforce its own architecture to avoid crumbling at the edges. This leads us to an extraordinary implication. The frontier of the universe might not be a passive boundary, but a site of continuous construction. At every moment, as space expands, the laws of physics must be reasserted in newly formed regions of space-time. Gravity must emerge, quantum fields must stabilize, time must take shape. Without this ceaseless reinforcement, the universe might simply dissolve into the formless chaos beyond. Expansion then becomes not a feature, but a burden, a responsibility of cosmic architecture, to maintain coherence against an external realm that tries to dissolve it. This opens the door to a chilling thought. What if the universe can fail in this task? What if its capacity to impose structure is finite? If so, then somewhere far beyond the observable universe, there may exist regions where the frontier has faltered, regions where space-time never properly formed, regions where the laws of physics glitch, flicker, or collapse. These could be the dark voids that seem disproportionately large. They could be behind the anomalies in cosmic microwave background radiation. They could explain certain asymmetries in cosmic structure that standard cosmology struggles to account for. Perhaps these anomalies are not random. Perhaps they are the fingerprints of a universe grappling with a hostile external realm. Imagine a cosmic frontier where space is thin, not in the sense of density, but in the sense of stability. A place where reality weakens as it approaches the boundary of non-existence. In such regions, the vacuum energy might fluctuate violently. Quantum fields might behave chaotically. The geometry of space-time might twist unpredictably. If a galaxy were to form in such a region, it might experience distortions that no physical model could explain. Stars might age faster. Light might warp strangely. Gravity might behave inconsistently. These would be symptoms of existential stress. Space struggling to maintain coherence as it pushes into the impossible. If the universe is expanding into a realm that should not exist, it must do so against resistance. But what form does this resistance take? It might not be a force in the conventional sense. It might be a limitation, an inability of the substrate to be molded. Expansion might require effort. It might require energy. Perhaps dark energy is this cost, the fuel burned to maintain existence at the frontier. If dark energy has increased over cosmic time, not due to internal processes, but because the external substrate has become more resistant, then the accelerating expansion of the universe might reflect the increasing difficulty of imposing space-time on a domain that fundamentally rejects it. This interpretation makes dark energy not a mysterious property of the vacuum, but a measure of cosmic struggle. It transforms the expansion of the universe from a passive phenomenon into a narrative, a story of a universe battling against the impossible. And if the universe must expand faster over time simply to maintain itself, then eventually the effort may become untenable. There might come a time when the frontier becomes too resistant, when the universe cannot impose structure quickly enough. At that point, expansion may appear to accelerate catastrophically, just before the universe tears itself apart at the edges. But if the external realm rejects our universe so fundamentally, why did the universe ever form at all? Why did existence erupt from non-existence? Perhaps this eruption was not natural. Perhaps it was an event of extraordinary improbability, a fluctuation so rare, so unlikely, that it defied the logic of the substrate. In this view, the universe is not a natural outcome of pre-reality. It is an anomaly, a violation, a cosmic mistake that has nevertheless persisted and grown. If so, then the expansion of the universe is the spread of this anomaly, the claim of a false order imposed on a realm where order should not arise. This raises an even more startling possibility. What if the substrate beyond the universe is not simply incompatible with existence, but actively hostile to it? Not malicious, but naturally corrosive. A domain where order decays, where structure unravels, where anything resembling physical law dissolves. If our universe were to stop expanding, this substrate might begin reclaiming the territory that space-time has carved out. Unlike the heat death predicted by standard cosmology, this would not be a slow fading of energy. It would be a metaphysical collapse, the dissolution of existence into primordial instability. This scenario inverts our understanding of cosmological timelines. Instead of expanding toward entropy and emptiness, the universe would be expanding away from dissolution. Instead of drifting into equilibrium, the universe would be fighting against erasure. It would mean that the universe is aging not because of internal processes, but because of the external pressure of non-existence pushing inward. If so, then the so-called fate of the universe, a cold, dark expanse over trillions of years, may not be its true ending. The true ending might come from outside, from the collapse of its frontier, from the moment when expansion can no longer keep the impossible at bay. But what if the external realm is not uniformly hostile? What if pockets of stability exist beyond the universe's frontier? What if the substrate is a patchwork of regions, some conducive to structure, others inimical? If so, then the universe's expansion might be directed, shaped by the landscape of possibility. It might expand more easily into some regions than others, resulting in anisotropies in the cosmic expansion rate. These anisotropies might be detectable in slight directional differences in the Hubble flow. They might appear as patterns in the cosmic web. They might reveal themselves in the distribution of galaxy clusters or in the shapes of cosmic voids. If the universe is expanding into a patchwork of variable resistance, then our cosmic structure is the map of that resistance. The cosmos becomes not a passive creation, but a dynamic response to the irregularities of a deeper reality. Galaxies form where expansion meets least resistance. Voids form where expansion struggles. The large-scale structure of the universe becomes evidence of the invisible substrate beyond. And yet, another layer of complexity waits beyond even this. If the universe is expanding into something that shouldn't exist, it may not be the only entity doing so. Other universes may form spontaneously elsewhere within the substrate. Each of them might impose different laws, different dimensions, different constants. These universes could expand as ours does. They could carve out domains of structure within the same impossible sea. They might grow in isolation or eventually collide. The substrate becomes a breeding ground, not for matter, but for realities. The multiverse becomes not a spatial collection of universes, but but a tapestry of expanding structures imposing order onto a chaotic background. If two universes meet, the encounter might not be symmetrical. One might have laws of physics more stable or more robust than the other. One might impose itself more aggressively. The resulting collision could produce a new unified reality or annihilate one or both universes entirely. From within our universe, such an event might appear as a sudden change in physical constants, a catastrophic rewriting of reality, physics breaking and reforming into something alien. But perhaps the most profound idea is this: maybe the universe is not expanding into a substrate at all. Maybe the substrate is expanding into the universe. Maybe the impossible realm is encroaching, pushing inward as the universe pushes outward, a cosmic tug-of-war at the frontier of existence. If so, the accelerating expansion of the universe might be the result of increasing external pressure. The universe might be fighting back, accelerating outward to prevent the impossible from invading. Existence versus unexistence, order versus chaos, law versus lawlessness. In this cosmic struggle, we are not spectators. We are part of the very pattern the universe is fighting to preserve. Our atoms, our thoughts, our lives are made of the structure the universe imposes. If expansion falters, we falter. If the frontier collapses, so do we. And so the universe expands, driven by a force more fundamental than physics, the need to exist. What if the universe is expanding into something that shouldn't exist? And what if the most astonishing consequence of this is not at the frontier, but here, within the familiar world we inhabit? If the universe's expansion is a process of imposing order on a substrate fundamentally resistant to structure, then the effects of this struggle may not be confined to the outermost edges of the cosmos. They may ripple inward, subtly shaping everything from the geometry of space-time to the behavior of matter, energy, and even consciousness. The universe's battle against an incompatible beyond might influence the formation of galaxies, the interaction of particles, and perhaps even the emergence of life. To understand this possibility, we must re-examine the universe from the inside out, not as a self-contained system, but as a growing pocket of order surrounded by a vast and turbulent sea of unlikeness. Consider the earliest moments after the Big Bang, when the universe was unimaginably dense and hot. According to standard cosmology, quantum fluctuations in this primordial state seeded the structure of the cosmos. But what if these fluctuations were not merely internal processes? What if some of them were external distortions, ripples created by the universe forcing itself into a substrate that resisted being shaped? The texture of the cosmic microwave background, with its delicate pattern of temperature variations, may not only represent early quantum processes, but also the stress lines of expansion against resistance. This possibility transforms the cosmic microwave background from a snapshot of the early universe into a map of its earliest conflicts. Imagine that in those first moments, the universe's frontier was under tremendous pressure. The rules of physics had only just taken form, stabilizing in regions as they expanded outward, but the substrate beyond did not provide support. It did not accept structure. It resisted. In this scenario, the initial period of inflation, the exponential expansion of the universe, might not have been a random burst of energy. It might have been an emergency response, a cosmic surge to escape an environment hostile to the very possibility of existence. Inflation would then be the universe's first great act of survival, a desperate expansion to carve out space where order could persist. This transforms inflation into something deeper than a mere mathematical explanation for cosmic uniformity. It becomes a narrative event, a moment when the universe, confronted by the incompatibility of the beyond, reacted by expanding faster than any physical process we can imagine. It was the universe saying, "If I do not expand now, I will not survive." After inflation slowed, expansion continued, but now under a more stable rhythm, governed by the delicate interplay between matter, energy, and the geometry of space-time. But if the universe's earliest stability came from outrunning dissolution, could later transitions in the universe's history reflect similar struggles? Consider the epoch of recombination, when atoms first formed. Before this time, the universe was opaque, filled with a plasma of particles unable to bind into stable structures. But when atoms formed, the universe cooled enough to allow photons to travel freely. The cosmos became transparent, and light gained the freedom to cross vast distances. What if this transition was not merely internal? What if the ability to form atoms represented another victory in the universe's ongoing struggle to impose structure? Before atoms existed, the cosmos was chaotic in its own way, dense, hot, turbulent. But beyond the frontier was a kind of chaos far more profound, a region where particles could not even be said to have meaning. When atoms formed, the universe may have strengthened its internal coherence, gaining the structural integrity needed to push outward once more. This pattern might repeat at every critical stage. Whenever the universe stabilizes internally, its ability to expand externally increases. Whenever it encounters resistance from the beyond, internal processes shift to compensate. This hints at a feedback loop between the inner and outer realms of existence, a kind of dynamic equilibrium between the internal structure of space-time and the external substrate it must impose itself upon. Now consider the formation of the first stars. For hundreds of millions of years, after the Big Bang, the universe was dark. Slowly, gravity gathered gas into the first luminous giants. When the first stars ignited, they flooded the universe with light and heavy elements. Stars created the chemical diversity that eventually allowed planets and life to arise. But what if star formation also served another purpose? What if the emergence of stars strengthened the universe internally, making it more resilient at the frontier? Stars are not just sources of light, they are engines of entropy. They accelerate the universe's journey toward greater complexity. They stabilize cosmic structures. They generate heavy elements that allow for new forms of order. Perhaps these processes increase the universe's ability to withstand the external pressure of the substrate beyond. The more complex the universe becomes internally, the better it may be able to project stability at its frontier. This raises a profound and unsettling question. Could life itself be part of this process? Could the emergence of complexity not be an accident of chemistry, but a natural consequence of the universe's need to strengthen its internal coherence? Life organizes matter. Consciousness organizes information. Civilization organizes both. Perhaps the universe's expanding frontier requires not just physical order, but conceptual order. Perhaps the emergence of minds capable of understanding the universe contributes to its ability to maintain itself. If this is true, then intelligence is not merely a biological phenomenon. It is a cosmological one. The universe may generate minds, because minds generate frameworks that reinforce structure. In this interpretation, consciousness is not a side effect of biology, but a strategy of existence. The universe produces observers because observers increase organization, and organization increases stability. And stability is necessary for expansion into the impossible. This idea leads to a staggering possibility. The universe may need us, not because we are special, but because we are functional. Our existence contributes to the universe's overall order, which strengthens its ability to expand into a substrate that resists being shaped. In this light, the evolution of intelligence becomes not a random event, but an emergent necessity in a cosmos that must constantly reinforce its internal structure. But if the universe requires internal order to maintain its frontier, then disorder might be more dangerous than we realize. Entropy increases over time, not just locally, but universally. If disorder grows too rapidly, the universe's internal coherence might weaken. This could reduce its ability to push outward, potentially allowing the external substrate to encroach. Perhaps the heat death of the universe is not merely the result of particles becoming uniformly distributed. Perhaps it is the moment when internal order becomes too weak to sustain the frontier. In this view, the ultimate fate of the universe is not determined by its internal thermodynamics, but by the struggle between internal order and external resistance. Expansion keeps the substrate at bay, but entropy works against expansion by dissolving structure. The universe may be in a race between its own internal decay and its need to maintain outward pressure. If entropy wins, the universe collapses, not into a big crunch, but into dissolution at the metaphysical frontier. Now consider the role of dark matter. This invisible substance shapes galaxies, anchors cosmic structure, and prevents star systems from flying apart. But what if dark matter is not merely a particle or field? What if it is part of the internal scaffolding the universe uses to reinforce its structure against external resistance? If dark matter contributes to coherence on galactic scales, then it may indirectly strengthen the frontier by stabilizing the internal architecture of space-time. This raises another possibility. Dark matter might interact with the substrate beyond the universe in ways we cannot detect. Perhaps it is sensitive to the conditions at the frontier. Perhaps the behavior of dark matter is influenced by the resistance the universe encounters as it expands. If so, then dark matter is not merely a mysterious component of cosmic structure. It is the interface between existence and non-existence, a mediator between the laws of physics and the substrate they must impose themselves upon. But the most profound idea is this: if the universe's internal complexity strengthens its external frontier, then the emergence of civilizations capable of altering planets, harnessing energy, and potentially shaping entire star systems may contribute to cosmic stability. A civilization capable of mastering physics at large scales could theoretically increase local order in ways that reinforce the universe's ability to impose structure at its boundaries. This transforms the role of intelligent life from an evolutionary curiosity into a cosmological necessity. Perhaps the universe needs civilizations not merely to exist, but to thrive. In this view, the universe expands into something that should not exist, but it succeeds because the internal forces of order continue to grow. Cosmic structure, chemical complexity, biological evolution, and intelligent thought all contribute to the stability required for the universe to maintain itself. The universe is not expanding alone. Everything within it is part of the effort. And if the universe ever loses this internal order, if entropy overwhelms complexity, then the frontier may fail. The universe may stop expanding, and the substrate beyond may reclaim everything. What if the universe is expanding into something that shouldn't exist? And what if this something has already begun shaping the destiny of the cosmos in ways we do not yet understand? If the universe is imposing structure on a substrate fundamentally incompatible with existence, then the consequences of this imposition may not be limited to cosmic origins or distant edges. They may be unfolding right now, woven into the laws of physics, embedded in the behavior of fundamental particles, influencing the expansion of space-time, and even dictating the long-term fate of everything. To investigate this strange idea, we must consider the possibility that the universe's large-scale evolution, its accelerating expansion, its formation of structure, its transitions from one cosmic epoch to another, is not merely a reflection of its internal dynamics, but a response to an external environment, a reaction to the substrate beyond. In this view, the universe is constantly adapting to conditions outside itself, reshaping its own internal rules in subtle ways to ensure survival. This implies that the universe is not a closed system, but an active, evolving construct that negotiates with forces beyond its borders. The first sign that something like this may be happening is the observed acceleration of cosmic expansion. Standard cosmology attributes this acceleration to dark energy, a mysterious phenomenon that permeates space-time. But what if dark energy is not intrinsic? What if it is reactive? Imagine the universe as a bubble expanding against a resistant medium. The more resistance it encounters, the more energy is required to continue expanding. The acceleration we observe today might be the universe struggling harder than ever to impose structure onto an increasingly hostile substrate. If so, then the amount of dark energy in the universe might not be constant. It might increase as resistance increases. Perhaps the universe is expanding into regions of the substrate that are more unstable or more incompatible with space-time. As it does, the cost of existence rises. The energy needed to maintain the frontier grows. This could explain why cosmic acceleration appears to be increasing over time. The universe is not simply expanding faster, it is fighting harder. But what happens if the resistance grows too strong? Could the universe reach a point where it cannot impose structure fast enough to keep expanding? This possibility implies a limit, a boundary beyond which expansion is no longer possible. Such a limit would represent not a physical wall, but a metaphysical one, where space-time simply cannot form. If the universe reaches this limit, several things could happen. One possibility is that expansion slows until it reaches a steady state, balance between internal stability and external resistance. Another possibility is that expansion stops entirely, causing the universe to become static. But the most catastrophic possibility is collapse. Not gravitational collapse, but existential collapse. A failure of space-time at the frontier that begins to spread inward. Before we contemplate such catastrophic endings, let us consider how the universe might sense or respond to the external substrate. If the laws of physics adjust subtly based on the universe's cosmic environment, then the constants we consider immutable may not be as fixed as we assume. The speed of light, the gravitational constant, the fine structure constant, they may all be dynamic, adjusting in response to pressures at the frontier. Even a tiny shift in these constants would have enormous consequences. Stars might burn differently, atoms might form with slightly different energy levels, chemistry might behave differently. Such changes could explain puzzling cosmic observations, such as variations in fine structure constant measurements across the universe. These anomalies might not be random. They may be signals from a universe adjusting itself to maintain structure. But what if the universe not only reacts to external resistance, but predicts it? What if the laws of physics contain built-in adaptability, enabling the universe to strengthen itself preemptively? If so, then emergence of complexity, including galaxies, stars, planets, biology, and intelligence, might be not accidental, but strategic. A universe facing increasing external resistance might require increasing internal order to survive. If the universe generates more complexity internally, it may create stronger gradients of structure that reinforce stability. For example, galaxies create deep gravitational wells, providing anchors for cosmic coherence. Stars support chemical complexity. Life organizes matter and energy. Consciousness organizes information. Advanced civilizations manipulate energy and matter at planetary scales. All of these processes increase internal order, countering entropy, and reinforcing the universe's internal structure. In this perspective, complexity is not simply a byproduct of physics. It is physics' response to the external environment. The universe is adapting, growing more complex because it must, because the frontier demands it. Now let us consider what lies beyond the frontier that could provoke such adaptation. The substrate beyond may not be a blank void. It may be a domain rich with chaotic potential, a region where countless unrealized configurations of reality swirl in a state of perpetual flux. If the universe expands into such a domain, it must constantly choose one configuration of order out of infinitely many possibilities. This could result in the universe occasionally flickering between states, with subtle shifts in physical constants, vacuum energy, or cosmic structure, reflecting changes in the underlying substrate. These flickers might be undetectable to us, or they might explain phenomena we struggle to understand, such as dark matter behavior, unusual gravitational anomalies, or the uncertain nature of quantum vacuum fluctuations. Perhaps vacuum energy is not intrinsic, but induced by the need to enforce stability at the frontier. Perhaps quantum indeterminacy reflects the underlying instability of the substrate. Perhaps the universe's deepest mysteries are not internal puzzles, but external reactions. Consider quantum entanglement. It defies classical intuition, linking particles across vast distances instantaneously. What if entanglement is not merely a quantum feature of space-time, but a mechanism the universe uses to reinforce coherence across its interior, a way to stabilize structure against external resistance? In this view, entanglement is the stitching that holds space-time together. Now imagine pushing this idea further. What if consciousness itself, our ability to observe, interpret, and impose conceptual order on the world, contributes to the universe's structural integrity? This is not mystical thinking. If the universe relies on internal organization to maintain coherence at the frontier, and if consciousness is a high form of internal organization, then consciousness may serve a cosmological purpose. The act of observing increases order. The interpretation of reality imposes structure. Minds may strengthen the very fabric the universe depends on to expand. But what about civilizations far more advanced than ours? If a civilization could harness energy on stellar or galactic scales, it could greatly increase internal order. Perhaps such civilizations are not rare. Perhaps the substrate beyond the universe demands so much internal organization that intelligent civilizations are necessary for cosmic survival. The universe may create civilizations because civilizations help the universe expand into the impossible. But if civilizations are necessary, why do we not see them? Perhaps they are too far away. Perhaps they exist in regions where the frontier struggles more intensely, where complexity must grow faster to stabilize space-time. Or perhaps they do exist, and their absence from our observable sphere is itself a clue. If the universe must organize itself internally to persist externally, then regions of higher resistance might require more complexity. Regions of lower resistance, such as ours, might require less. This brings us to an unsettling idea. The substrate beyond the universe may not be uniform. Some regions may be more incompatible with space-time than others. Expansion might be easier in some directions and harder in others. This could create large-scale anisotropies, directional differences in cosmic expansion that we have only begun to detect. For instance, some studies suggest the universe expands slightly faster in one direction than another. If confirmed, it could indicate that the beyond is pushing back unevenly. If the universe expands into an irregular landscape of incompatibility, then cosmic structure is not accidental. It is the visible imprint of the invisible substrate. Voids form where expansion meets resistance. Filaments form where resistance is lower. Galaxies cluster along the veins of possibility. The cosmic web becomes a map of the universe negotiating with the impossible. But what lies at the ultimate frontier? What is the nature of the impassable boundary the universe might eventually reach? One possibility is the zone of absolute incompatibility, a region where the substrate simply cannot be shaped into space-time with any amount of energy. If the universe ever reaches such a region, expansion will slow asymptotically. Space will stretch thinner and thinner until the effort required to impose structure becomes infinite. In this scenario, the universe approaches a cosmic asymptote, a smooth, fading into structural exhaustion. Another possibility is catastrophic. The universe hits a wall of sheer impossibility, causing the frontier to fracture. The fracture propagates inward, collapsing space-time from the edges toward the center. This collapse is not gravitational, it is existential. Structure unravels, quantum fields destabilize, time disintegrates, reality dissolves into pre-reality chaos. But there is a third possibility, perhaps the strangest of all. The universe may never reach an ultimate boundary because the substrate is infinite, but the resistance may continue increasing forever. Expansion accelerates, driven not by dark energy, but by necessity. Eventually, the universe expands so rapidly that structure can no longer form. Galaxies drift apart faster than stars can shine. Matter becomes isolated. Complexity collapses, not because the universe is dying internally, but because the frontier becomes too resistant for structure to be maintained. In this fate, the universe does not freeze or collapse. It is stretched into oblivion by the effort to outrun impossibility. Expansion becomes self-defeating. The universe becomes too thin to function. Existence fades, not at the edges but everywhere at once. And through all of this, the cause is the same. The universe expanding into something that should not exist. What if the universe is expanding into something that shouldn't exist? And what if the most profound consequences of this expansion have not yet occurred? If the universe is growing into a substrate fundamentally incompatible with space-time, we must confront a far more unsettling possibility. Perhaps the universe is changing in ways we have not yet learned to detect. Perhaps the laws of physics we consider unbreakable are slowly adapting. Perhaps reality itself is preparing for a transformation driven not by internal evolution, but by pressures imposed from outside. Imagine for a moment that the universe is not a static system, but an organism, a self-maintaining structure that evolves based on environmental pressures. In biology, organisms adapt to survive in hostile environments. Species evolve new traits when confronted with new challenges. If the universe is expanding into an unfriendly substrate, perhaps it too must evolve. Perhaps the laws of physics are the universe's genetic code, mutable, adaptable, capable of shifting when necessary to ensure survival. Could physical laws evolve? Could space-time adjust itself at cosmic scales? Though radical, this idea is not entirely foreign to theoretical physics. Some models suggest that physical constants might vary over time. Others propose that the number of dimensions might change under extreme conditions. Still others imagine universes forming with entirely different sets of physical rules. If these ideas hold even a grain of truth, then the laws we observe today may be snapshots of a system in flux. The universe may be modifying itself as it expands into a domain of possibility and impossibility. Now, imagine that the external substrate, the realm that shouldn't exist, exerts pressure on the universe not in terms of force, but in terms of structure. Perhaps space-time responds not to physical forces, but to structural incompatibility. Where the substrate is more chaotic, space-time must become more rigid. Where the substrate is more formless, space-time must impose stronger geometric constraints. This might explain why the geometry of the universe appears so uniform. It is not an accident of inflation alone. It is the universe enforcing coherence to protect itself. If this interpretation is correct, then cosmic evolution is not merely physical, it is structural, a negotiation between existence and non-existence, each exerting influence on the other. The universe imposes structure on the substrate pushes back with instability. Over time, this negotiation might intensify, requiring deeper adaptations within the universe itself. But what might those adaptations look like? One possibility lies in the behavior of vacuum energy. Quantum field theory tells us that empty space is full of fluctuating energy, but the energy we observe is vastly smaller than what theory predicts. This discrepancy, known as the cosmological constant problem, is one of the greatest mysteries in physics. But what if vacuum energy is low not because our models are wrong, but because the universe has tuned it to be low in order to maintain stability at the frontier? If vacuum energy were higher, space-time might be too volatile to impose structure at its edges. If it were lower, the universe might collapse internally. Perhaps vacuum energy is not a fixed constant, but an adaptive parameter, a structural balance point shaped by the pressure from the beyond. Now consider gravity. Unlike the other forces, gravity is extraordinarily weak. A single magnet can lift a paperclip against the gravitational pull of the entire Earth. Why would gravity be so much weaker than the other forces? Some theorists suggest gravity may leak into extra dimensions. But perhaps gravity is weak because the universe needs it to be. If gravity was stronger, the universe might collapse before it could expand into the substrate. If gravity were weaker, matter might never clump into galaxies. Perhaps gravity's weakness is not a coincidence, but an adaptation, a finely tuned parameter that allows the universe to maximize internal coherence while pushing outward. This line of thinking leads to an even more profound idea. The universe may be self-regulating. Whenever the external substrate exerts more resistance, the universe adjusts internal parameters to maintain expansion. Whenever the internal structure becomes unstable, the universe compensates by altering the conditions necessary for stability. This does not imply consciousness or intention. It implies a deep, mathematical self-consistency. The universe prefers configurations that allow for continued existence. If the universe is self-regulating, then the evolution of complexity, including galaxies, stars, planets, and life, may not be random. Complexity may stabilize internal structure, making the universe more resilient against external instability. This could mean that complexity is not merely allowed by physical laws, it is demanded by them. Entropy must increase locally, but perhaps complexity must also grow to counteract the rising instability at the universe's expanding edge. If complexity must grow, then advanced civilizations might play a critical role. A civilization capable of manipulating energy on planetary, stellar, or even galactic scales could strengthen local regions of space-time, reinforcing order. Megastructures like Dyson spheres or galactic-scale engineering projects might increase informational and structural density, making the universe's interior more robust. This interpretation suggests an answer to the Fermi paradox, the question of why we do not see evidence of advanced civilizations. Perhaps such civilizations are required for cosmic stability, but they arise only in regions where the universe encounters higher resistance. Our region may encounter relatively low resistance at the frontier. Thus, fewer advanced civilizations are necessary. Perhaps we live in a cosmic backwater, a calm region where complexity evolves more slowly because the universe does not require reinforcement here. If this idea holds, then our existence is part of a cosmic strategy, but not a central one. We are contributors to the universe's internal order, but not essential players. Not yet. As the universe expands into increasingly incompatible regions, the need for internal complexity may increase. Civilizations may grow more numerous as the universe grows older. Perhaps our era is one of relative calm, before the universe faces greater challenges at the frontier. But what if the need for complexity grows faster than civilizations can arise? If the universe requires more internal order to compensate for rising external instability, it may enter a phase of structural stress. In such a phase, physical constants may begin to drift more rapidly. Stars may behave unpredictably. Matter may become less stable. We might see unexplained anomalies in particle behavior, cosmic structure, or vacuum fluctuations. Some of these anomalies may already exist. The accelerating expansion of the universe might be accelerating too quickly. Certain regions of the cosmic microwave background appear colder than they should be. Large-scale cosmic voids are larger and emptier than expected. The distribution of galaxies shows asymmetries that defy standard cosmological models. These might be early signs of structural stress, regions where the universe encounters greater resistance from the substrate beyond. If structural stress increases, the universe may need to stabilize itself more aggressively. This could lead to phase transitions, sudden shifts in the laws of physics. These transitions might be akin to the formation of atoms after recombination or the decoupling of forces in the early universe. But future transitions might be more dramatic. The universe may reorganize itself on a fundamental level to maintain expansion. New forces might emerge. Old forces might weaken. Dimensions might shift. Such transitions could be catastrophic or invisible. We might not notice them if they occur far from our region of space-time, but if they occur near us, everything could change. Matter might behave differently. Time might flow differently. Even the concept of distance could shift. Yet the most profound possibility is this: the universe may one day reach a point where adaptation is no longer possible. The substrate beyond may become so incompatible that no amount of internal adjustment can maintain expansion. At that moment, the frontier will begin to fail. What does frontier failure look like? It does not look like a black hole or a firestorm. It begins subtly. Regions near the edge begin to destabilize. Quantum fields lose coherence. Vacuum energy fluctuates wildly. Space-time geometry becomes jagged and inconsistent. These instabilities spread inward, like the frayed edge of a fabric unraveling. Over vast cosmic timescales, galaxies near the frontier dissolve. Stars disintegrate as the laws governing them fluctuate. Planets lose cohesion. Molecules unravel. Eventually, the collapse reaches regions closer to the center of the universe. But before it can reach us, the universe may attempt one final adaptation, a shift into an entirely new mode of existence, a transformation of space-time into a new configuration capable of withstanding the external substrate. This might look like a sudden change in the geometry of the universe, a shift in dimensionality, a new form of matter, or a redefinition of physical law. It might be so dramatic that nothing like atoms or stars exists afterward, or it might be subtle enough that intelligence could persist through the transition. Alternatively, the universe might fragment. Instead of collapsing entirely, it may break into smaller, stable regions, pockets of reality that survive independently. Each fragment becomes its own universe. The original universe does not end but splinters, like a crystal shattering into pieces. And all of this, every shift, every collapse, every adaptation, would be driven by the same fundamental cause: the universe expanding into something that should not exist. What if the universe is expanding into something that shouldn't exist? And what if the final chapter of this expansion will reveal a truth so vast, so alien, so beyond comprehension, that it redefines what we mean by existence itself? Throughout this exploration, we have considered that the universe may be expanding into a substrate incompatible with structure, perhaps even hostile to it. We have imagined the cosmos adapting, evolving, fighting to maintain order against a backdrop of instability. But now we must push the question further than ever before. What if the universe's expansion is not only an act of survival, not only an imposition of order upon chaos, but a transformation of the impossible itself? To explore this final possibility, we must think in terms beyond physics, not abandoning science, but transcending its current boundaries. We must imagine that reality is not a binary division between existence and non-existence, but a continuum of states that range from the fully structured to the fully unstructured. If the substrate beyond the universe is a realm of unstructured potential, then the expansion of the universe might be transforming that potential into actuality. Every new bubble of space-time created at the frontier might be carved from raw possibility, shaped into the structured reality we experience. In this interpretation, the universe is not merely expanding into non-existence, it is converting non-existence into existence. If this is true, then the universe is not a passive observer of its environment. It is an active creator, a generator of reality, a transformer of possibility into structure, and its expansion is the mechanism by which that transformation occurs. This leads to a profound question. Why is the universe capable of such transformation? Why does space-time possess the ability to impose structure on a substrate inherently incompatible with structure? The answer may lie in the nature of the Big Bang. Perhaps the universe began as a fluctuation powerful enough to imprint a structured pattern onto unstructured possibility. Once this pattern existed, it propagated outward, expanding like a fractal, an algorithm of existence unfolding into an environment that resists being shaped. Think of the universe as a flame in total darkness. The flame burns outward, illuminating the void, converting absence into presence. The void does not want to be illuminated. It dissipates structure, absorbs order, dissolves patterns, but the flame persists. And the more it burns, the more it transforms the darkness into something capable of sustaining light. Yet no flame burns forever. If the universe is a flame consuming non-existence, then its expansion may be limited by the energy available to sustain that transformation. Dark energy might serve as the fuel of this cosmic fire. As long as dark energy remains sufficiently abundant, the universe can impose structure on the beyond. But what if dark energy is finite? What if the universe's fuel supply is not infinite but merely large? Eventually, the flame might weaken. Expansion might slow, the frontier might waver, and the darkness beyond might begin to reclaim what the universe has transformed. This metaphor is not merely poetic. It reflects a deeper physical idea. The universe's ability to expand may depend on the energy it can harness to enforce structure at the frontier. If the substrate grows more resistant with time, the universe must expend more energy to maintain expansion. Eventually, it may reach a critical threshold where the energy required to impose structure exceeds the energy available. At this threshold, the universe faces a transition. It cannot continue expanding as it has. It must either collapse, transform, or find a new mode of existence. Let us examine each of these possibilities. The first possibility is collapse. As expansion slows, the frontier becomes unstable. The substrate beyond begins dissolving space-time. The universe unravels from the outside inward. This collapse is not a reversal of expansion. It is a failure of structure. Galaxies dissolve. Stars unravel into quantum mist. Time loses coherence. Eventually, the universe returns to the unstructured potential from which it emerged. The second possibility is transformation. Instead of collapsing, the universe may undergo a phase transition, a reconfiguration of space-time that changes the rules of existence. Perhaps the universe could shift into a state with different laws of physics, enabling it to impose structure more efficiently. The universe might adopt new constants, new dimensionality, or new forms of matter. This transformation could be abrupt or gradual, catastrophic or subtle, but it would mark a new stage in cosmic evolution. The third possibility is transcendence, the most speculative, yet perhaps the most profound. If the universe is converting unstructured potential into structured existence, it may eventually transform the external substrate so thoroughly that the distinction between inside and outside dissolves. In this scenario, the universe becomes the substrate. Order permeates the chaos. The impossible becomes possible. Existence rewrites non-existence. If this happens, the universe would no longer expand into something that shouldn't exist. It would have transformed the very nature of the beyond. The frontier would vanish because the outside would become compatible with existence. The universe would no longer be a bubble. It would be the totality. But this outcome requires one condition. The universe must achieve internal coherence so strong, so absolute, that it can impose structure effortlessly. This requires complexity to increase dramatically. It requires that the universe develop mechanisms, perhaps emergent, perhaps computational, perhaps cognitive, that enable it to reinforce coherence across infinite scales. In this view, the ultimate fate of the universe depends on the growth of internal order. Complexity becomes not only beneficial, but essential. Intelligence becomes not only probable, but necessary. Perhaps the universe must evolve observers, beings capable of understanding and shaping the cosmos, to achieve the coherence required to endure. Perhaps consciousness is not an anomaly, but a tool the universe uses to strengthen itself. This possibility transforms the meaning of civilization. An advanced civilization capable of manipulating space-time might not merely exist within the universe. It might participate in shaping the frontier. It might help the universe impose structure on the beyond. Megastructures could stabilize regions of space-time. Controlled fusion and energy manipulation could increase local order. High-level computation could simulate and reinforce the laws of physics. The most advanced civilizations might operate not as isolated cultures but as cosmic stabilizers. In such a cosmos, intelligence becomes part of the universe's immune system, a defender of structure, a guardian of existence. Now consider a more speculative scenario. What if the universe itself develops a kind of emergent consciousness? Not a mind in the biological sense, but a complex, self-reinforcing network of information spanning the cosmic web. If consciousness arises wherever information becomes sufficiently interconnected, then the universe, filled with galaxies linked by gravity, magnetism, and quantum entanglement, may already be evolving toward this state. It may become self-aware in the most literal sense, an entity that understands itself, adapts itself, and ultimately sustains itself. In this interpretation, the universe expanding into something that shouldn't exist is not only a physical process, but a cognitive one. The universe is learning. It is discovering the structure of the substrate by interacting with it. It is adapting based on what it encounters. Observers, like us, are part of this learning process. We are instruments of cosmic self-understanding. When we study physics, we are participating in the universe's effort to comprehend its environment. When we discover new laws, the universe discovers them through us. When we extend knowledge, we extend the universe's capacity to adapt. If this is true, then the fate of the universe may depend in part on intelligence, on the growth of knowledge, the expansion of understanding, the development of civilizations capable of shaping reality itself. Perhaps the universe cannot survive without intelligence. Perhaps intelligence is the mechanism by which the universe transforms the impossible into the possible. And yet, we must consider the opposite. What if intelligence fails? What if complexity collapses? What if entropy overwhelms order? In that case, the universe may lose its ability to impose structure on the frontier. Expansion may falter. The substrate may invade. Existence may dissolve. This paints a stark picture. The universe is in a race between entropy and complexity. If complexity grows faster, the universe strengthens. If entropy dominates, the universe weakens. This is not merely thermodynamics. It is cosmic evolution. It is existence struggling against non-existence. And therein lies the final revelation. When we ask, what if the universe is expanding into something that shouldn't exist? We are really asking a deeper question. Why does anything exist at all? The answer may be that existence is not a static state, but an active process. A process of imposing order on chaos. A process of expanding into the impossible. A process that requires effort, adaptation, growth, and complexity. The universe exists because it continues to create existence. It continues to transform the impossible into the possible. And we, tiny conscious beings on a small planet orbiting an unremarkable star, are part of that process. We are the universe expanding into understanding. We are existence confronting non-existence. We are the mechanism by which the universe imposes structure on the impossible. And perhaps in the end, that is what existence truly is. The struggle against the impossible. Thank you for watching. If you enjoyed this video, leave a like and share your thoughts in the comments. Send it to someone who you think would enjoy this topic too. And of course, subscribe and turn on the notification bell so you don't miss the next videos. See you next time.